My name is Jahangir. Today I will discuss how to design an earthquake resistant building. We all know what is earthquake, but we need to understand when we design the building, what are the consideration we should take into account. Two things can happen. The first thing, if the building sinks, then we can do nothing. But if building does not sink, it stays on the ground, then we can design the building in such a way that it can withstand the force. And to discuss this, I am to consider two scenarios. The first case, let's say when a person is in a stationary car or in a stationary lorry, he gets panicked, but he does not scared of death, that something will happen to him or going to kill him, because when he or she is in a stationary car or a lorry, when the earth shakes, then the wheel it moves a little bit and nullify or cancel the force. There is the second scenario. Say when the ship is in an ocean, it is subjected to rolling, and still nothing happens to that ship. Why? Because they have got a mechanism that the ship will sway, but it's not going to destroy. So when we design the building, we have to take into account the same mechanism. If we are able to introduce the same mechanism to nullify or cancel the earthquake force, then the building will be safe to use. Let us consider, or let me discuss, or let me tell you how to do this. At first case, let us consider this system. There's a footing, there's a column going, and there's a beam connecting. Sometimes the beam connects here, and you can have pile underneath, no matter what, but that's the basic scenario. This is very old style, and lots of people follow it, and lots of buildings have been made on such structures. So what is the problem if we design a building and the foundation like this? The problem is, when the earthquake will come, when it will strike the building, it will shake the building holding the footing, and it will affect on the beam or on this column joint. So these structures, when you try to design a building on such a system, then your building is vulnerable for earthquake. So if you want to design a building, always try to avoid such foundation. So what is a better structural choice of a designing foundation? You always choose, or you ask your engineers to design the building on a mat foundation or raft foundation. What is the benefit? The benefit is, if you just visualize, you don't have to be an engineer, you just visualize. If your foundation is a mat foundation or raft foundation, and if it does not break, and if it stays on a solid concrete foundation, then your columns are not going to be affected. If the foundation is solid, the whole structure will be safe. Another thing, always try to design the buildings on shear wall. Try to introduce more shear wall on the buildings rather than on columns. And another thing, when we design the building, we should try to put the shear walls on the outside. That means on the exterior face, we should try to put more shear walls. There will be shear walls on the inside, but it will be better to put more on outside. Let me explain you why. Let us take an example or take an example from nature. If we consider a jute plant or a sugarcane plant, we can see the sugarcane plant is only 1 inch or 1.5 inch in diameter, and it grows almost 10 to 12 feet high. And a jute plant is only 1 centimeter in diameter, and it grows 7 to 8 feet high. So it takes only very small basement, but it grows very tall. And you see, on the nature, these plants, they survive on high wind. How did they do that? Because the tension mechanism is on the outside, not on the inside. And this is how these plants withstand the wind load, or we can say external force. So when we design the building, we have to learn from the nature. Always try to make your tension member strong on the outside. So try to make more shear walls on the outside. Another design we can follow, this is this design. People can say it can be expensive. It is expensive, but I think if someone makes it, then other will follow. What we can do, we can make a strong mat foundation or wrap foundation underneath. Then we could put roller underneath, and we can make another basement. Then we can make one building or 2 building or 3 or 4 building or more. The advantage of this is when the earthquake will come, it will shake this basement, and when this basement will shake, then this will shaking like this. This will be like a round shape. Just consider you're putting a bearing ball on a cup, or just think you put a bearing ball on a round circle, and when you move it, the bearing ball moves like this. So if there's any earthquake comes, this base will move, and this is moving like this, but it's not going to harm your building. So this is a very good technique which will ensure you safety for a long time. And no matter what is the magnitude of the earthquake, it will guarantee your safety. And another thing is we can design the buildings in a modular frame. Modular frame means you can design the building part by part. Even if the earthquake destroys some part of it, we can remove it part by part, and we can transfer to a new place, and we can fabricate them back again. And the future of the building, to my understanding, it will be not only civil, it will be civil and mechanical together. So when in the future, when we will think more about safety, and we will try to design an earthquake resistant building which will guarantee us safety no matter what is the magnitude of the earthquake. Definitely it will break in 9, but up to 7 or 8, this model will survive. The basic and key is the earthquake force will hit the basement, but it's not going to hit. When we hit the basement will shake, and the second basement it will just move horizontally, and the people inside the building, they can feel a little bit, but the most of the shock will be absorbed with the movement. And that's all for this video. Thanks for watching the video.